All right, please. Here we go now for this chapter 4, 1 through 4 review. All right. What I feel like the best thing for me to do would be go down and do the odds with you. All right. Then in the other class, I'll do the evens. All right. And then you just have to do a little bit of studying. All right. Write each expression using exponents. I'm pretty comfortable with that. Make sure you know that is -4 to the what? Yes, -4 to the third. All right. Now listen, Max, you guys, I'm looking back. I'm not sure what you guys are doing. I'm doing the math. All right. Connor, stay with me now. There's number 1. All right, now it says for number 3, write each expression using positive exponents. We talked about that a bunch. Whenever there's a negative exponent, you have to move it. So, Abby, tell me what number 3 would be.
1 over x to the 6th.
That is exactly correct. 1 over x to the 6th power. Any questions with that? All right, now let's take a look at number 5. Number 5. Now, where people make a mistake on this is they forget that the first k is to the what? First power. So if I multiply that, Julian, that's right. So I would end up with k to the 7th. That is correct. Perfect. You're adding exponents. You're adding exponents. All right? Now here we go. We're going to work on some scientific notation. So we're going to write this number in standard form. From yesterday, Max, what would I have to do?
You have to move the decimal
To the right or to the?
Oh, to the left.
Yes.
Oh, to the
So
left.
how many zeros do I need to add?
4.
That's correct. Very good. So it'd be a decimal. 1, 2, 3, 4. 3, yes. And then 3, 4. Anybody have any questions with that? Everybody good? All right, let's take a look at number 9. 9 should be pretty okay with you. Y times y times y. If we're going to use exponents on that, Will, what would that be?
Number 9, it's y to the 3rd.
Yes, y to the 3rd power. Very good. All right. Now number 11. It says, how do you divide monomials with the same base? What was the rule for dividing?
Subtraction.
Yes. What do we do? Subtract exponents. All right, let's just write that down. Subtract exponents. All right, you got to subtract the exponents. All right, let's give you an example. Let's say, for example, I said x to the 8th divided by x to the 2nd. That would be x to the what?
6.
X to the 6th. Everybody okay with that? 13. Hold on a second. 5 to the 9th divided by 5 to the 8th. Julia, what do you think? 13. Yes, 5 to the 1st. Now, I want you to write 5 to the 1st, but I also want you to know it's just what? Just 5. All right? Let's go ahead and do 14. All right, I want everybody to take a look at 14. All right, Madeline, what do you think?
12x.
Yes, everybody okay with 12x to the 8th?
Yes.
12x to the 8th power. 12x to the 8th. All right. All right, Will, what do you think 15 is? Yes, z to the 4th power. All right, again, we're dividing, we're subtracting exponents. All right. Let's talk about 17 now. It says the number of cells in a lab sample triples every 4 hours. Write the expression that represents the number of cells after 24 hours. All right, this one's actually kind of hard. Sebastian, what do you think you need to do?
So I think we should do 20 C before over C
No, let me try to explain this to you, right? All right, everybody write this down for me. Everybody look up. I'm going to try to teach you something, all right, that I haven't really shown you, but I think it's important for you to understand. All right. I want you to write cells here. I'm sorry, I want you to write time, and I want you to write cells. Do that for me. You're supposed to be on 17 though. All right, now you're going to miss 17. All right, first of all, when time is 0, how many cells are present?
0, 3.
Well, wait a minute. Okay, that's kind of my mistake. All right, so basically, I'm sorry, I misread this. I was thinking they were saying something about 24. All right, so let me instead of writing it as a table, I need to show you something else. You just pay attention on this one. This one's a little bit tricky because we haven't done something like that, but I still want you to know. So, all right, so it says the number of cells in the lab triples every 4 hours. All right, and it says write an expression to represent the number of cells after 24 hours. All right, so when you start off with something, here's what I want you to do. We don't know how many cells we start off with, right? So that's X. Think of it like that. All right, that's how you're going to start. All right, you're going to start with something unknown. All right. However, in 4 hours, all right, in 4 hours, how many cells are going to be present? Tell me. No. No. X times 3. Thank you. Smart. That's what I want. All right, because you're going to triple it. You with me? And triple means multiply by 3. Everybody with me? So after 4 hours, you're going to have 3x. All right, everybody with me? Now, after 8 hours, you can tell me how much we're going to have after 8 hours. How many cells? Go ahead, take a shot, Julian. It's okay. What am I doing every 4 hours, Julian? Well, does it say I'm adding or does it say I'm doing what? By what? Yes, you're multiplying by 3. Right, it should be 9x. Okay, it should be 9x. And then after 12 hours, you should be what? Yes, you should be 27x. And then after 16 hours, you should be at what? 81x. Thank you. And now after 20 hours, you would be at what? Wow, very good job, buddy. That wasn't that hard because you're practicing your mental math. 243. And now my final one would be after 24 hours. But instead of multiplying 243 times 3, it's easier to multiply 81 times 9. You with me? So then that would be what? 729x. Does everybody agree with that? All right, so now listen, you can put a little star by this one. This one's hard, but now I'm going to try to show you something else. All right, I'm going to try to show you something else. So please try to pay attention now. All right, that would be how you would do it when you don't know much about exponents. All right. Now, what did I do from step to step to step? Always multiplied by what? 3. So what I did was I multiplied by, or I took x, I multiplied it by 3, then I multiplied it by 3, then I multiplied it by 3, multiplied it by 3. So once, twice, 3, 4, 5, 6 times. Does everybody see what I did there?
Mm-hmm.
So if you wrote that as an exponent, it would be what? 3 to the 6th power. So 3 to the 6th times x is equal to the number of cells. All right, equal to the number of cells. All right, is everybody okay with that? All right. Now again, that was kind of tricky, so I want you to review what I just said. All right, look that problem over because I think that one's kind of hard. All right. Again, what does X represent? I want you to make this note to yourself. X represents the number of cells that you start with. All right, the number of cells that you start with. Okay? All right, let's continue on now. Now we're going to write some scientific notation. So, Avery. So let's take a look at 19. What would that be written in scientific notation? Wait, 19. 4.0 times 10 to the 8th. Perfect. Ellis, what about 21? You sure? No, 4 is good, but it should be. Yes, there you go. Double check that. Remember, your decimals require negatives. The decimals require negatives. So it's 4.8 times 10 to the negative 4. All right? So Caroline, b to the negative 2. How do I write that with a positive exponent? What would that be? Yes, 1 over b squared. That's easy. Everybody good with that? All right, 25. It says, suppose a wildfire is doubling in size every 6 hours. If the initial size of the fire was 1 acre, how many acres will the fire cover in 2 days? This is kind of what we were just talking about. All right, so it starts out at what? 1 acre. So I want everybody to put 1 acre down. And actually, I want you to do this. Do me a favor. When time is 0, do me a favor. When time is 0, you have 1 acre. Is everybody good with that? So then, what happens in 6 hours? Right, so in 6 hours, it'll be how big? 2 acres. Does everybody agree with that? It will be 2 acres. All right? You with me? So now, in another 6 hours, time would be what? 12. At t equals 12, what would we be at? 4 acres. Is everybody okay with that? And at t equals 18, you would be at what? 8 acres. And at t equals 24 hours, you would be at what? Help me. In 24 hours, you would be at how many acres? 16 acres. Now, that's just what? That's just 1 day, right? And we got to do how many? So we got to get all the way to 48. Does everybody agree? So after 24 comes what? 30. So after 30, I would have what? Yes, 32 acres. And then at 36, I would have what? 64 acres. And after 40 hours, I would have 128 acres. And then after wait a minute, it wouldn't be after 40. I was thinking 4 hours. It would be 42. I'm sorry, guys. It'd be every 6 hours. And then after another 6 hours, we'd be at what? 48, which then means what? Your fire would cover what? Yeah, 256 acres. We covered 256. Now notice what I did here, guys. I did a nice little pattern that I would hope you would be able to do. All right, does everybody see that? All right. So at t equals 0, you'd be at 1 acre. T equals 6, 2 acres. You just count down to what? You count down to 48. All right. The reason why we're doing 48 is because that would be what? 2 days. It's 48 hours. Yes, ma'am. Yeah, I don't know, to be honest with you. We didn't really do that, but I still see, I kind of want you to just see the logic in that, right? And again, I understand you might be a little confused right now. I don't want you to worry about it, but I kind of want you to see the pattern. Does that make sense? I don't want you confused, right? And I don't want you going into the test feeling, like that's so hard, right? It's just you haven't seen it. Right? Do you understand what I'm saying now? Can you see the pattern? I really would kind of want you to see the pattern on that. All right? What?
So all you do is multiply by 2?
Why?
Because it's 2 days?
No. It says because.
Oh, doubling.
Right. The previous one we were doing what? Tripling. And tripling means to do what? Multiply by 3. Doubling means to, multiply by 2. All right? I'm okay with that. All right, hopefully I kind of answered your question. Just go back and if you're studying, if you're worried about a particular problem, just look at the problem over and do it 2 or 3 times. Make sure you understand what I'm saying. Okay? Which now brings me to 27. Now, I did put on here a bunch of kind of review questions too. All right. So how would we write 8 over 25 as a decimal? What's the quickest way to do that? What do you think?
Multiply 8 times 4.
Yay, very smart. That's exactly right. We're going to multiply by 4, so that would become 32 over 100. And now you can easily see that's the decimal. Yes, 0.32. The answer is 0.32. Everybody okay with that? Right? Okay, let's take a look at 29. All right, so how would I write that as an exponent? Colin, what do you think about 29?
So, since all of them are the same equation,
That's right.
we put them in parentheses, and then we do the equation.
Yeah, so what's the exponent?
The exponent. Right? The exponent is like times like 10.
Well, but in this case, how many 2y minus 9s are there?
It's 5.
That's what the exponent would be.
Yeah. So 10 to the 5th power.
Yes. 2y minus 9 to the 5th. That makes sense now?
This would be 7y to the 5th times 10 to the 5th power.
No.
No, not I said just like 7y to the 5th power.
No, I think you're making a mistake. I think you're thinking of something else, to be honest. We're not writing in scientific notation. All right?
I'm not going for scientific notation, but like what idea?
So you're literally just counting how many 2y minus 9s there are.
That is 5.
That's right. That's why we write it as 2y minus 9 to the 5th.
Oh, that's it?
Yep, that's all I'm asking for. Okay? All right. Now, let's do 0.001. Now listen to me on this, guys. 0.001 is the same as what fraction? 0.001. Now remember, you're reading that, all right? So this spot right here is the tenths, then the what? Come on, guys, help me. Hundredths, and then the what? So that's the same as what fraction? Yeah, that's what I want you guys to know. Remember, that's the same as 1 over 1,000. All right? Now, 1,000, right, is the same as 10 to what power? 10 to the third, right? So we could write that as 1 over 10 to the third. Now, That is also the same as we need a negative exponent. How can I write that as a negative exponent? Sebastian.
You can do 1.
No. What would it be?
10 to
Yes, 10 to the negative 3. Come on, Sebastian. I need you to pay attention to me. All right, 10 to the negative 3. 10 to the negative 3. Is everybody good on that? All right. Now, let's take a look now at, let's take a look at 33. All right, 6 to the 4th times 6 to the negative 8 is what? Kind of tricky. 6 to the 4th times 6 to the negative 8.
Oh,
Max, what do you think?
36 to the
No. Big mistake. Don't make that mistake tomorrow. What is it? Yes, very good.
Oh,
So remember, when you're multiplying, you'd leave the bases the same. However, we still are not allowed to use the negative exponent. So from there, Will, what am I doing? How would I write? Yes, 1 over 6 to the 4th. 1 over 6 to the 4th. That is correct. 1 over 6 to the 4th. Okay? Now let's talk about 35. All right? It says, the table shows the approximate diameter of Mars and Neptune. About how many times greater is the diameter of Neptune than Mars? We talked about this. Whenever you want to find out how many times greater something is, you'd have to do what? You'd have to divide, right? You want to find out how many times. So to figure that out, you have to divide. So now we're going to take Neptune, which is 2 to the 15th, and we're going to divide it by 2 to the 12th. And what was the rule for dividing? What do you do for exponent? Yeah, we're going to subtract. So my final answer here would be what? 2 to the 3rd. Now, because 2 to the 3rd is a relatively easy number, 2 to the 3rd is the same as what? 8. Thank you, Ellis. It's 8. So what I prefer you do is just say it is actually just what? 8 times greater. It is 8 times greater. All right? Everybody okay with this? All right, let's take a look now at question 37. The number of neurons in the neocortex of a human brain is 3 times 10 to the 10th. All right? And the gorilla is 7.5 times 10 to the 8th. Who has more? And don't let them trick you on this. Colin, who has more?
Human.
Right. Again, because what's important, not the number, but the exponent.
Yep.
10 is greater than 8. So you can just circle the human. All right? Now, for question 39. All right? Now, what number is twice as great as 7 times 10 to the 3rd? What do you think? Ooh. So look here, guys. What is 7 times 10 to the 3rd? What is 7 times 10 to the 3rd? The same. 7,000, right? So that's kind of how I would look at it first. That's how I'd want you to do it. And then I would want you to say, well, what number is twice as big as that? Well, wait a minute. Yes, but I would prefer you just say what? 14,000, right? I would want you to just say 14,000. Okay, so 14,000 is the answer, but again, our lesson is on scientific notation. Our lesson is on scientific notation. So now I'd like you to write the 14,000 in scientific notation. All right? So it'd be, thank you, What was it? 1.4 times 10 to the 4th. All right, 1.4 times 10 to the 4th. Now, if you want to do it the other way, it actually would be 14 times 10 to the 3rd. But 14 times 10 to the 3rd is not written in scientific notation. All right? All right, let's go ahead, continue now. Let's look at 41. So 41 again is kind of a review. So what's x times z? What is x times z? 9, correct? Divided by the y, which is what? 3. So our answer is just 3. All right, Sebastian, listen, stop now. All right, let's just do the problems and get it over with. All right, 9 divided by 3 is 3. Girls, you all right in the back so far? All right. 43. Now for 43, we want to do 1/3 times, now what's x? -9 times y times z. All right. Now how many decimals are not how many decimals, but how many negatives are involved? 2, right? So the answer itself is going to come out to be what? Positive. Does everybody see that? Now, again, let's take a look at this. What is 1/3 of 9? 3. Right? And then 3 times 3 is what? 9. So our final answer is just what? Just 9. All right? The answer is 9. Does anybody have any issues with that? All right. Let's take a look at 45 now. So again, 9 times x minus 6 times -1 minus 9 times 3. All right, so being careful with that. 9 times 9 is what? 9 times -9 is -81. And then -6 times -1, +6. And then -9 times 3. There you have it. Okay. So now, -81 plus 6 minus 27. All right. We came up with what? -1. I think -102. How's everybody okay on that? All right. Everybody good? All right. Now we're just reviewing our integers, which shouldn't be a problem. So everybody take a look at 47. The double negatives make it what? Positive. So that's just what? 85. Good. Now again, back to practicing our integers. 11 times -7. -77. 51. -56 divided by 8. -7. All right. Now let's look at 53. All right. It says at 6 a.m. the temperature in San Diego was 82. By 2 p.m. the temperature had risen 102 degrees. Oh, I'm sorry, had risen to 102 degrees. What is the difference? Well, that should be pretty easy for you guys. What is it? Shh. Don't come in. All right. Number 53. All right. So from 82 to 102 was what? 20 degrees. So I'd want you to say 20 degrees Fahrenheit. 20 degrees Fahrenheit. All right. 54. Or I'm sorry, 55. I want to write that as an exponent. All right, Abby, what are you thinking about 55? Good. Good job. Wait a minute. Look up. Look up at the board. You're not doing them individually, right? You're not doing them individually. So 2d minus 1 and 2d minus 1 is written as 2d minus 1. But it's to the what power? to the second. You with me now? All right. Does anybody have any questions with that? Anybody have any questions? Okay. So now 57, 11 to the 7th times 11 to the 4th. Jesse, what are you thinking about that?
So I think it should be negative.
No, 57.
Oh. So then that should be 11
Come on.
to the
When you multiply, what do you do to exponents?
you add them.
That's right.
So that'd be 11.
Yay, 11 to the 11th power. 11 to the 11th power. Okay, here we go. 59. All right, nice little problem now for 59. B is 2. So let's make the substitution. 4, parentheses, 2 times 2 plus 1 to the 3rd power. All right, remember our order of operations is we have to do what's on the inside first. So if we do what's in the inside first, what's 2 times 2 plus 1? 5. Right, so now I have 4 times 5 to the 3rd power. Now, at some point, we've been doing the exponents long enough. Everybody here should be able to quickly say 5 cubed or 5 to the 3rd power is what? 125, right? Because 5 times 5 is 25, and then you have 5 quarters. Everybody with me on that? If you think of it like that, all right? So then it's 4 times 125, and 4 times 100 is 400. 4 times 25 is another 100. So altogether, we're looking at what? 500. What time's the bell ringer? You guys trying? All right. Okay, so listen, again, guys, there's lots of problems here. I want you to do as many as you can tonight. Tomorrow we'll come and we'll finish everything up, right? But try to do everything tonight. And that way tomorrow we're just going to be studying.
Okay, that's going to be hard. That's going to take me like 20 hours.